Okay, it looks like most people are admitted here. So, welcome to the Grain Farmers of Ontario Grain Talk webinar series focusing on soil fertility. I'm Laura Ferrier, an agronomist with Grain Farmers of Ontario, and thank you so much for joining us today. This is the first of three webinars, this one being focused on soil sampling, the how, the why, and the when. The following two webinars are focused on the interpretation of results, turning analysis into recommendations, plus credits for manure and cover crops and tools to use. And the third and final of the series is on how to take a recommendation and turn it into a fertilization plan. So by registering for this webinar, you will also get access to the remaining two webinars. And while each webinar stands on its own, the series is designed to tell a larger story, from soil sampling to building a fertilization plan and implementing that plan. So we encourage you to attend all three webinars. This webinar, as well as the remaining two, are eligible for CCA, CEUs, and off-CAF KSEs, and QR codes will be available at the end of the presentation. This presentation is being recorded and will be posted on the Grain Farmers of Ontario YouTube channel for future reference. Also, with our remaining two webinars, we'll send out this webinar recording. So if you want to brush up on anything from this webinar prior to watching the remaining two, you can do that as well. We, of course, welcome and encourage questions, but we'll aim to ask them all at the end of the presentation. At that point, you're either welcome to unmute and ask. You can ask in the chat function with Zoom that I can then read out loud at the end, or you're also welcome to direct message myself at any point, and I will happily share the questions with our guest speakers. Now, I'm thrilled to have three speakers here with us today. I have Caleb, Danny, and Colin. They're all here to share various insights throughout the webinar. And I'll just take a brief moment now to introduce each speaker, and then I'll let these three guys take it away. So first, we have Colin Elgie. Colin is the soil fertility specialist with field crops with the Ontario Ministry of Agriculture, Food, and Agribusiness. Colin's focus is to improve the agronomic, economic, and environmental aspects of soil and crop nutrition while learning from farmers and researchers across Ontario. Colin has been with OMAFA since 2022, and prior to that, which he worked as an agronomist at an ag retailer in southwestern Ontario for 13 years after graduating from the University of Guelph with a Bachelor of Science in Agriculture. Colin holds his CCA designation with the 4R NMS specialty. Danny Jefferies is the agronomy lead and CCA at Honeyland Ag Services, leveraging his expertise in soil and agricultural practices to help farmers optimize crop production. With a proven track record in consulting and agronomy, he excels in delivering tailored solutions and fostering collaboration to enhance agricultural outcomes. And we also have joining us today Caleb Niemeyer, an agronomist with Woodrill Limited and head of Groundwork Digital Soil Mapping, a service to provide farmers with high-quality soil data for use in precision ag. Caleb has his Master of Science and Bachelor of Science in Agriculture from the University of Guelph, and he is currently completing a PhD in plant agriculture, focusing on the analysis of on-farm trials. Thank you to all three of you so much for being here with us today. I can't wait to hear what each of you is going to share. And now I will pass it over to Colin to get his presentation started.
Yeah, thanks, Laura. So I'll start off here. All right. So my part of the presentation today is maybe a little more of the basics around soil sampling, but I think probably one of the most important parts when it comes to sampling is the why. So, not just how we do it, not just when and where we do it, but why we're sampling is so incredibly important. And I think we're going to touch a little bit on that today on why that's important. But then our next two webinars in this series, we're going to really dig in to find out, where exactly that soil sample leads and why that's so important in the overall picture of farm profitability. So there we go. So it comes down to the basic question of why should I soil test my field? And really what it means is we want less of what we see here, so nutrient deficiencies. We want that plant to have the nutrients that it needs to grow and thrive. And we want more grain. So no matter if we're growing a crop of corn, soybeans, wheat, barley, what have you, uh, what we're trying to do with our business overall is really get that grain, that output to sell. And
Hmm. Hmm.
there we go. And when it comes to soil testing, what we're trying to do
What's that?
is figure out the right amount of
Oh,
fertilizer
okay.
that we need. And so if we can apply, the least amount that we need to grow our crop profitably, well, that's money that we don't have to spend. That's profitability that goes in our pocket. And we also want to look at some of the environmental aspects as well. So uh, when it comes to soil sampling and really the overall soil fertility aspect of what we do within our farm operations, what we're trying to do in a lot of cases is prevent some of that excessive fertilization, maybe the placement, the timing of that fertilization, that we don't utilize that fertilizer. And so this is the algae blooms that have occurred in the Great Lakes for the past number of years now, to varying degrees of severity. But really, what this shows is that a lot of that nutrient that we may be applying to our field isn't necessarily staying on that field, and in some cases can be leaving and moving to the Great Lakes, which can cause some issues with algae. And whether or not that algae is negatively affecting the drinking water that you may be using. It does affect a great number of people, some of the species in there. And really, it also comes down to the economics of we're applying fertilizer that if it's not staying on the field, we're kind of throwing that money away. And so, it's that whole picture that we want to look at, to reduce the losses of that fertilizer, keep it on the field that we need. And so soil testing is kind of the first step to really figuring out where and when we need to apply that and what we need to apply. So the one thing that I want to touch on here is that in a lot of cases, what we're doing with that fertilization is trying to replace the nutrients that crop will pull out when we go to combine it. So I've got three different crops here: corn, soybeans, and winter wheat. And just looking at the crop removal of them over some different time periods. So if we look at a 1985, and the 5-year average that we had across Ontario at that time was about 97 bushels of corn, 34 bushels of soybeans, and 54 bushels of winter wheat. And so I've got the phosphorus and potassium removal numbers there. And so that may be what we were applying 40 years ago, to really replace the nutrients that we were pulling out. If we fast forward to last year's final numbers, so about 40 years later, we can see that we've increased the yields of those crops dramatically. And so the nutrients that we're removing from the field have increased quite drastically as well. So the fact is that if you're still using the same fertilizer program now that you used 40 years ago, it may be time to look at it and see if that fertilizer program still makes sense for what your yields are actually pulling out of the soil, and whether or not that fits your overall fertility plan. And then if we look more towards the future, and this, for a lot of us, this may not be the future anymore, but this may be kind of current yields that we're actually dealing with on a, somewhat regular basis in a lot of cases. 275 bushel grain corn used to be something that we only heard of in the States in yield contests and that kind of thing, but it's pretty widespread in some areas now. And same with soybeans and wheat. We've got some fantastic crops that Ontario growers are growing now. But the fact is that we're pulling a lot more nutrients out of that soil. And so, that's one thing. If we've got high soil test levels and we're looking to draw them down, maybe that's a good thing. But if we've got low testing soil already, that may be where we're looking to build those up a bit more. But if we don't have that soil test, we really don't know where we're starting and where we need to go. So if we kind of look at Ontario as a whole, what I'm showing here is a soil test summary. So this is the soil test labs in Ontario kind of compile their data anonymously and look at just how the relative frequency of different testing soils. And so they do this throughout the states as well. But what we're looking at here is just the Ontario data. So we've got 5 different colored bars here showing the survey from 2001 on the left in the bright blue, and 2020 is our latest data in kind of the bluish purple on the right of each of these. And what this graph shows is the frequency that those samples are analyzed at different soil test levels. And so this is showing Bray P1, which is a different extractant than we regularly use in Ontario, but still gives an indication of some high testing soils and some low testing soils. So what we can see from this is that our very high testing soils, we're dropping the frequency of those. So we've got less of those total soil tests that are very high, and that's a good thing. So if we've got a soil test with 50 parts per million or more of phosphorus, that's something that we can generally look at as excessive phosphorus levels. And that's where we have a lot of that risk of runoff, loss of soil, loss of that phosphorus nutrient. And so decreasing those levels is actually a good thing to decrease the risk to the environment. But if we look on the other end, we've got an increase in the number of low testing soils that are coming through. So what that does is basically means that more of that soil tests are coming through with some lower values, and that can limit productivity. So we know that in very low testing phosphorus soils, we can run into issues of deficiency and just not having enough for that soil. So the fact that the frequency of those testing soils is climbing is kind of an indication that we may not be replacing what we're actually pulling out of the soils in a lot of cases. And same thing if we look at our potassium test summaries, we can see that it's a little bit different pattern, just the way that it's laid out. But we've generally had kind of a similar trend over the past number of years. The 2020 data is out, which may show some differences in that general trend. Maybe we're kind of looking at replacing a bit more of that nutrient, or it could be just a matter of different soil tests coming through. But looking at the overall trend over the past 20 years, we can see that those low testing soils, there's more of them going through the soil test labs. And so it generally shows that that soil test potassium is declining as well. And so we look, are we changing the trend with that 2020 data? Really need to see what 2025's comes out like when they do this survey again to really see, whether we're actually moving in the right direction or not. And the one thing that, again, those very high potassium testing soils, again, the fact that they're dropping is generally a good thing. But if 2020's data shows a bit of an increase, well, we don't necessarily need to be applying fertilizer to those high testing soils. So it all comes down to the soil test report. We'll get in the next couple of weeks, we'll get a bit more into how we get through this soil test report and what that actually means. But this is kind of the end goal when it comes to soil sampling is getting a good, accurate soil test for the area that you're pulling that soil test from. And so I'm going to go through a little bit here of, what the whole purpose of that is. So we want to know the nutrient capacity of the soil with the soil test. We want to know what that crop needs to grow. And that by combining those, we can really come up with our overall fertility plan. So to get through a bit of the basics here that you've likely heard this all before. But I think this is something that's incredibly important because every year we do see some issues with, the not necessarily the analysis itself, but how that soil test was taken. And in a lot of cases, the results that come back, they seem off, they're inaccurate. And in a lot of cases, it's related to how that sample was taken, where it was taken, when it was taken, and in some cases, using improper equipment. So, uh, key is that we want to use stainless steel as much as possible or plastic. We want to avoid any galvanized metals anytime we're taking that soil sample. That galvanized the zinc coating can actually affect the nutrient content within that soil, and so it can throw some inaccuracies, especially when it comes to micronutrients. So we want to make sure that we're using stainless steel and plastic as much as possible. Also want to make sure that we are labeling the box and bag and making sure that matches the submission form. No matter what lab you're using, it's incredibly important to have that that box or bag labeled correctly. Not just so the lab knows where it goes and how it goes, but so you can look back on your records later and actually figure out, well, where did I take this sample? Why did I take it? All that kind of stuff to be able to make a decision with that. And we also want to look at using the right depth. So, different jurisdictions, if you go to some of the states, they talk about taking a 4-inch core or an 8-inch core. Some will go down to 12-inch. But when it comes to our standard nutrient tests, so looking at things like pH, phosphorus, potassium, we want that 6-inch or 15 centimeters depth across the board. So, no matter if you've got a topsoil that's 3 feet deep, or if you're looking at a very shallow topsoil, if you've got some rocks, we're still looking for that 6-inch depth. It's important that that's the depth we use because that's where the majority of our nutrient uptake comes within our roots, with our crops. And we've got the depth calibrated for all of the test extractions that we do in the lab. So if we're pulling more or less of that soil, it will affect the nutrient levels. And I think we'll get into that a little bit later, how exactly that affects it. But we want to make sure that we clear the surface crop residue before sampling. It's especially important if we've got a thick layer of residue after wheat or corn, for example. Can not only affect how that core actually comes out, but can overestimate something like organic matter, potassium levels if we're pulling, more crop residue or less out from within that soil core. We also want to take at least 20 cores per sample. In some cases, it's quicker to pull 4 cores and say it's representative, but we know through a lot of research that that's not enough, that we need more cores to get a more accurate representation of that area that you're sampling in. We also want it at the right time. So every 3 to 4 years works with most of our field crop systems. Ideally, we're making that part of the rotation, so it's something you don't really have to think about. It's corn, soybeans, wheat, and then soil sample, or corn, corn, soybeans, soybeans, and soil sample. We want to have that as a regular part of that program to know how those nutrient levels are, also how they're changing, and what that means moving ahead. Maybe something more frequent if you're on sandy soils or if you're planting and growing crops with a high nutrient uptake. You may want them more frequently. But some of the key factors, and this is something that, again, we run into every year, is we've got the soil sample before manure's been applied, before fertilizer's been applied, and before tillage comes through. For the fact of we don't want any nutrients that may throw off that whole analysis with the manure or fertilizer. And also with the tillage, it's very difficult to get a good representative soil core when we've already had tillage go through the field. And that's important that we want that 6-inch depth of soil. And so if we're getting a mix of some surface soil, subsoil, or even just a kind of an unstandardized mix that we may get with tillage, it can throw that analysis off quite a bit. And if we look at the right place, we want to make sure that we're locating our fertilizer bands if at all possible. So anytime that we're applying a starter in a crop like corn or we're doing strip tillage, where we apply that fertilizer can affect how we sample. So we know we've got in a lot of cases, a high nutrient content within that strip that can really throw out our whole analysis if we grab too many samples out of that or too few samples out of that. So we want to try and average that out so that we're sampling within that core, or within that band to represent how frequent that band is across the field. So if we're looking at a 2x2 band in 30-inch rows, maybe one out of every 20 cores you take within that band. For strip tilling in a 10-inch wide zone, maybe one out of every three that you want to take from that strip tilled zone. And in a lot of cases, we may not know. We may be sampling, a year after that band has come out. And in that case, if we can't locate where that band was, we simply want to take more soil cores. So we've got a greater chance of getting an even distribution if we take more soil cores and mix them together as our subsample to send away. We also want to avoid, specific areas that may affect that kind of representative balance of nutrients. So next to roadways, the picture I've got here is actually one that a field that I went out to a few years ago. The grower had a crop next to a gravel road, and we took some samples there. Looking at the field, we eventually figured out that it was salt that was causing that issue, basically not being able to grow, and a lot of that was coming off the salt used on the road. The dust control agents can play a factor. So being sure that we're aware of those, odd spots, we want to avoid them when it comes to our overall soil fertility analysis. It is important to take samples within those spots, but keep them separate from the rest of what you're doing when it comes to looking at those problem areas. So things like manure piles, lime piles, if we've got highly eroded knolls, we generally want to sample them separate in order to keep that analysis as representative as possible. And we want to use the right lab. So the key is that whenever we're soil sampling, we want to make sure we're doing it right, but we've also got to send it to the right lab for analysis. So the important factor is that we're using an OMAFA accredited soil test lab, and we've got a list of them that I've got a link in the next slide. But it's important to notice that there's a lot of different soil test labs, not just in Ontario, but in other states, provinces that can do lots of different soil tests on lots of different soils. But we want to make sure that what we're looking at are the extractants, the tests that will actually work with Ontario soils due to things like our soil's parent materials, the depth of our topsoil, all that kind of thing, that we want to make sure that we're actually giving results that work for the farms that we're growing crops on. And so when it comes down to it, we look at a good example of that is phosphorus. So phosphorus is one that our OMAFA accreditation, we use sodium bicarbonate, or also known as an Olsen test, to test for phosphorus within our soils. There's lots of other tests that can be done, but the research that shows that goes into this accreditation program is that we want our test to work with our soils, and we know we've got a wide variety of pHs within our soils. And so the researchers have tested exactly how each of those extractants work within the different soils. And so the way to read this chart is essentially it's correlating the different extractable phosphorus levels from each of these different extractants and comparing them to known values within different pHs of soils. So the closer to 1 you are means you're completely accurate each and every time. The closer to 0 you are means you may be very variable, unlikely to have correlation. So a high testing soil may or may not read high, a low testing soil may or may not read low. So if we're looking at our sodium bicarbonate, that is our accredited test on the top row, and then another very popular test that's used in a lot of the states, the Bray P1. We can see that across the wide variety of pHs that we've got in the province, in each case, the sodium bicarbonate extraction performs best. And so it's important that we want to use this because we want, a standardized test so that you don't have to send part of your field to one lab and part of your field to another or use different extractants. But we want them to work with the same extractant to give the best results across all of our fields. So OMAFA accredited labs, I've got a link here, but if you look up OMAFA accredited labs on Google, you'll be able to find a link to this. And so again, it all comes down to the soil test. And I've got shaded here our OMAFA accredited tests. So pH, buffer pH, phosphorus, potassium, magnesium, zinc index, and manganese index are all ones that we use as kind of our standard package. And nitrate is one that we do a bit different type of sampling on, a little bit deeper sampling, and in different times of year, but it's also accredited. So no matter how you sample, doing it right is a critical start to your fertility plan. And I think that's incredibly important that no matter what you're looking for within that, you've got to have that right to begin with. And so the last thing I'm going to touch on very quickly here is soil health testing. And this is kind of a new analysis that we're looking at in Ontario in a lot of cases. But it's looking at the health of that soil, giving a risk assessment of what's going on within that soil to help compare different soils and look at different best management practices that we can use. So it's one thing that we're in testing now, and a lot of different analyses than the chemistry side of things, but looking at that kind of that organic that soil life, but also how well that soil can hold together, how it can hold water, how it can hold on to that carbon within. And so that soil health assessment and plan, or SHAP, is one of these tests where we can really look to get a bit better picture on how healthy a soil may be. And so with there, I've kind of covered the why and how. Now I'm going to pass it on to Danny to give a little bit more on the when, and really look at how that affects our overall plan.
Excellent. Thanks, Colin. Um, Appreciate the opportunity to participate in this today. Yeah, as mentioned, my name's Danny. I work with a agricultural company and laboratory near Elsa Craig, Ontario called Honeyland Ag Services. Um, I think I have control of the slides here now. Let's just take a peek here. Here we go. Yeah, so I was asked to give a little bit of commentary on the when of the soil sampling and timing, and I'll share a couple of case studies and some curiosities we've explored at Honeyland here. But I think when it comes to sample timing, especially when we're talking soil fertility and managing it over time and wanting to compare our fields and our sample locations over a period of time, it's important that we are consistent with when we are collecting our samples. So if we're collecting in the fall, we should also be collecting in fall the subsequent sample timing to ensure we're comparing consistent time frame. As Colin mentioned earlier as well, kind of simple things. It makes most sense to align our timing with our crop rotation rhythm. If we're in that traditional corn, soybean, wheat rotation, post wheat harvest is always a great window to collect some good soil test information And part of the reason it's such a good time is that usually that aligns well with our management decisions that we're making when it comes to bulk fertilizer applications and trying to build some of our soil fertility levels. More and more, we're seeing some opportunities and good consistent results with spring sampling as well on the winter wheat crop itself prior to that jointing phase, kind of that March, April frame. This works really well, giving everybody a little more time to breathe and kind of work with some of that data and make some of those management decisions over the beginning part of the growing season to be ready for some fertilizer applications later that year. And then also, as mentioned, with some of those nitrate tests, those are very important that we take at specific timing to when we're doing our nitrogen fertilization. So with our pre-side dress nitrate test, having that as close to the nitrogen application in that June timeframe as possible. So some commentary around timing though is understanding the nature of what we're dealing with when it comes to soil. Soil is dynamic. It's a living system. There's microbiology, there's living things in this soil and so because of that, things change within the soil depending on how much moisture there is, whether it's more wet and more dry, warmer, colder. Things are going to change chemical forms within the soil. And so ultimately, soil moisture at the time of sampling can definitely influence measured levels that we see in our laboratory extractions. Um, but I did want to make a comment. As far as I understand, all Ontario laboratories are drying their soil samples before conducting the soil extractions in the lab. There are some newer technologies where people are working with soil moist samples to do the extractions on moist soils, but it's pretty standard practice within the laboratory world to be drying samples and grinding them prior to extraction. The last comment just to make about uh, this current year too is it was very dry, but even a recent soil sample collected this year is going to be much more reliable than one that was collected 3 or 4 years ago. As Colin mentioned, there's a lot of crop removal that's occurring over these times with these high yielding crops. There's changes in our applications that have been made. And so it's important that we're basing our fertility decisions on current information as best as possible. And so this dynamic nature of soils, I have a bit of a case study of something we did here near the lab, my coworkers in 2019, 2020. So it's on a clay loam soil near the lab here in Elsa Craig. And so 2019 was a much different year than we had this year. If you can think back there, it was a very wet spring. We had some late planted corn. The corn got planted well into June here around this area. And so what was done was we went back to two different locations within this field, a high slope position, so shown as the blue points here, the high K, and a low slope position in orange here, the low K. And we sampled within that same local vicinity, collected a bulk sample from a small area every 2 to 3 weeks, and took that back to the lab to measure our soil test levels from those exact same spots. We're not sampling the exact same soil, obviously, but we're coming from the very close proximity. And so this figure shows soil test K levels on the y-axis in parts per million, and then the date of collection along the x-axis. And I think what immediately jumps out to you is there's a lot of variability here in the soil test values that we read based on the timing. Um, in this orange site, the low slope position, we're upwards of 150 down to 100 parts per million. That's a pretty wide range of soil test value, and not much different in that blue high slope position. But I wanted to add some commentary to this time series data as well to try to give a little bit of background of what was going on in that environment when those soils were collected. And so this initial spike we see in the orange is was a sample that was taken shortly after corn planting. And so usually this is not a good time to collect soils. And one of the reasons, and I think what happened here, is we more than likely caught a little bit of that starter fertilizer band in our collections there, which caused a spike in our soil test levels versus the high K did not have that. When it came to August, so our August 23rd samples, we see we've kind of hit our lows here on soil tests that we've read. And this ground was very hard. I won't say it's as dry and hard as probably what we experienced this past summer, but it was definitely very dry at the time of soil collection here. And we saw some lower test values come back. Go to December, we see some spikes again here in our soil test levels. That's when we started sampling on some frozen ground, which may explain some of these peaks. And then again, the ground became unfrozen and kind of stabilized a bit. Interestingly, manure was applied that spring. Sampled after that, there wasn't as much of a spike in soil test values as we expected after that liquid manure application. But I think my take home message in showing you this time series data is yes, definitely soil test values change depending on the time of year and the amount of moisture in the soil and different things going on in that environment. But if we are explaining some of this and are avoiding some of these situations. So avoiding sampling near that corn planting, avoiding in really, really dry conditions, avoiding soil sampling on frozen ground, perhaps. Then we start to stabilize our soil test values quite a bit. And so we definitely still have some variation, some ups and downs in what we're reading. But if we can understand that there are some environmental extremes that occur and maybe use some of our critical thinking to avoid soil sampling during those times, we should be able to acquire a more consistent soil test result uh, as we go and collect them. So similarly on the phosphorus side of things, so soil test phosphorus now on the y-axis, same dates on the x-axis. Same kind of commentary here. Corn planting saw that same spike again on our phosphorus levels where we caught some of that band. In the hard ground, one of our samples spiked, the other one went down a bit. I have a bit of an explanation perhaps to this that I'll elaborate on in a bit. Frozen ground again, we saw a spike in our phosphorus levels and then some more stabilization as we got out of that winter season into the springtime of the following year. So again, if we avoid these um, extreme situations, we start to get more stable numbers in our time series and our data collection. So I think that just to reiterate is the take-home message of this time series um, demonstration is to avoid some of those environmental extremes. If it's really dry or really wet or even frozen, those are probably not the best times of year to be collecting good quality soil test information. And so using those fringe seasons of the fall and the spring to really gather the best information for your decision making that's going to represent that field most accurately. So in that time series data on the phosphorus side, we saw a bit of a spike in that orange line on the low slope position. And this is something as we were collecting soils this summer that was definitely happening. If you've ever tried to probe soils in some very dry conditions, it can be very difficult in these clay-based soils to get to our standard 6-inch depth collection. And so I think this is one of the biggest error potentials for error in soil testing is the actual collection that we're doing and the depth that we're getting that probe to. And as more and more of our agricultural systems have moved to minimal tillage and we're still doing some bulk fertilizer applications, we're seeing some nutrient stratification in particular of phosphorus within the top few inches of our soils. And so if we were only sampling a 4-inch depth soil core, we're right in the thick of that nutrient-rich zone, which may be inflating the numbers versus if we collected the full 6-inch depth core. We get into some of that lower testing soil at further depth, which is what our fertility recommendations in Ontario are based on our 6-inch standard assessment. And so this is going to give us the most accurate information of what's going on in that 6-inch profile. And so this past summer we did a bit of a demonstration or a case study here, excuse me, to just explore this phenomena a bit. And I think this is fairly common in many fields is the stratification that we see in phosphorus. So there's a lot going on this graphic here, but there are two two rows here. So there's a row at the top here, which represents a field that's traditionally been disked to 2 or 3 inch depth. And a second field near the lab here that we've been to that has been plowed fairly regularly within the rotation and gotten a lot of soil mixing. And what we did in these dry conditions this summer was we collected a 3-inch depth core, which is the yellow bars. We collected a 6-inch depth core, which is the blue bars, and a 9-inch depth core, which is the green bars. And I think it's pretty apparent when you look at the disked field with that shallow tillage that we certainly have stratification of that phosphorus within those upper few inches. Our 3-inch soil tests are much higher than a 6-inch depth soil test, and again, even higher than the 9-inch depth soil probe. Whereas within the plowed system, it's pretty consistent with depth across all 5 of the sample spots. We um, uh, collected our data that there's more mixing in those systems. And so if we collected a 3 or 6-inch core, we seem to get a pretty similar soil test result. And so I think a couple take-home messages here. The one for sure, just being that we want to make sure we're getting to that 6-inch depth as that's what our fertility recommendations are all calibrated to, and that's going to give us the most informative information for um, making our management decisions. But secondary to this, I think this really hits home the placement side of the fertilizer applications, in which if we're doing broadcast applications of phosphorus on our fields, phosphorus is moving very little within our soil systems to depth. And so getting that phosphorus placed near the seed in the starter band or with the seed and is the most effective placement of that phosphorus. So I don't want the take-home message to be to go and plow every field to get this soil mixing, but more to just identify that we need to sample to the proper depth, and secondary to that, we need to be placing the phosphorus in a way that it's going to be accessible to that plant. So when we did the same analysis, but for potassium this time, there is still stratification in the disked field. You can see that there's higher soil test levels at the 3-inch depth versus a 6-inch depth soil probe. But it's not to the same degree as phosphorus. So we're getting much more movement of that potassium through the soil profile, whereas the phosphorus is much more concentrated in that surface horizon. Um, so not all nutrients behave the same way in the soil. So a bulk application of potash is still a good method to build our soil test levels and get that into our soil systems. So another curiosity of ours, I was asked to comment a bit too on some of the dry weather effects and different things. So when we were out sampling this summer again, you get probing and you're in your bucket of your composite sample, you have a lot of really fine, almost powdery, dusty stuff that's in the top inch or so of your soil probe. And then in the clay-based soils, you get the rest of it is more intact and kind of holds the shape of your soil probe. So what happens when you're mixing that all up in the bucket and you end up sending to the lab more of these soil cores or more of this soil dust or vice versa? Is this dust really concentrated, high phosphorus stuff at the surface? It's going to impact your results if you get more of that and less of the other in there. And so we were curious to explore this. Um, so this is just a single location, just a curiosity, not replicated or anything, but for what it's worth, when we look at the dust versus the cores, there's definitely differences in soil test levels that were measured. The dust generally has a little bit higher bicarb levels, a little bit higher potassium levels, um, but they're not significantly different where you're probably going to be making different management decisions if you got these slightly different numbers. They're within the same ballpark, I guess, is the take home here. Um, be interesting to do some more replication of this and explore it some more. But this gives me a little bit of confidence to think that that's not going to impact our soil test results very much. On the texture side of things, we got a little bit more sand within that surface dust, which kind of makes sense. The sand kind of falls out of the cores a little bit more. And then organic matter wise, very comparable between the dust and the cores, near to that 2.5% organic matter. Yeah, so with that, yeah, thanks for signing on to the webinar today. And I'll turn things over to Caleb to give some commentary on the spatial aspects of soil sampling.
Sounds good. Thanks, Danny. Thanks, Colin, too, for the all the information that you guys have. Definitely some interesting stuff there. Let me just make sure that I'm able to share my screen here. There we go. Okay, so yeah, my name is Caleb Niemeyer, and I'm an agronomist at Woodrill Farms, just outside of Guelph. And I also head up the digital soil mapping business of Woodrill, which is called Groundworks. That's our precision ag arm of our business. And so I'm going to be talking today about a few different things, but they all kind of come from the base foundation that Danny and Colin were just talking about, for following some good practices for taking soil samples. So I'm going to be talking about bulk sampling, right? And so not too much into depth there, but basically what Danny and Colin have talked about. And then some zone sampling, grid sampling, and then also followed up with some sensor-based sampling, and then some different comparisons of all those different methods. So to get into things here, so you take a sample for one sample per field that you bulk it in, just like Colin and Danny were talking about. And this is useful for tracking trends over time. It's cheap and you can do it yourself, so that's definitely a pro. I would say that though that there can be some variable results, especially if you're not taking into consideration of some of those best management practices that Colin and Danny were talking about. Um, and then I would also say that the biggest problem that I see with bulk sampling is that you're taking an average of the field, and averages may hide problems that exist throughout the field. So if we look at these two different soil cores with the topsoil on the left-hand side going down to the subsoil on the right-hand side, these are some cores that we've taken through Groundworks soil mapping program. So the top core here, both cores come from the same field. The top core comes from an eroded knoll, very steep slope. The bottom core, again, from the same field, but from a depressional area just a couple feet away. And so obviously very different soil types. And so if we take a sample from that knoll and then also mix it in with that depressional area, we might get some average results, right? So if you say the topsoil there is a pH of 7.7 because it's had quite a bit of erosion, it's mixing in the subsoil with the topsoil, increasing our pH because our subsoils in Ontario are often very high pH. But if we mix that high pH soil with a low pH soil, and then we get up with a pH of, let's say, 6.9 or something like that, for the two soils, we would say, okay, that's fairly good. We don't have to worry about pH. But the problem, of course, is that there could be situations where we do have to worry about pH and other situations where we definitely don't need to be adding more lime to an already fairly high pH soil. And so that's where we want to get into things to look at how do we manage that spatial variability throughout the field. And so the first method that I'll kind of talk about is grid sampling. So this is one of our approaches that we can use to represent field variability. And so how you do it, it's kind of in the name, but you take samples from a set grid size, excuse me. So that could be either 1 acre or 2.5 acre grids that are common in Ontario. And this requires many lab samples and a lot of labor to pull those cores from the field. So here in this little picture, let's suppose that's a 100-acre farm. Obviously, if you're taking 1 acre grids, that's 100 samples that you have to actually go out and pull those cores from. So a lot of cores that you'll have to go through. And it also brings up the question of, well, what's the best grid size, right? Because obviously it's more expensive to do the finer resolution grid size, but it's also you also get higher accuracy, right? So this kind of, if you look at this little diagram here, there's 4 points here in the 1 acre grids. But if you move it to the 2.5 acre grids, then you're basically averaging those 4 points into 1 point from the center of that grid cell. And so here if this value here is 100 ppm, this one's 170. Obviously, there's a lot of variation within that 2.5 acre grid cell that's able to be shown in that 1 acre grid. But of course, there's the trade-off with the increased cost, right? So this leads into the question of what grid size is best, and I won't answer that here, but I'll talk a little bit about that a little bit further on in the presentation when I actually show you some real life data for that for a farm. The next approach here that you can do is grid sampling, or sorry, zone sampling, I mean. This is, of course, where we break fields into zones and then we bulk sample each zone. So the idea is that we're trying to make uniform areas in a field to then take soil samples from. And so we can do this with multiple different layers of data. We can use topography data, yield data, imagery, and or sensor data to create these zones in many different ways. And I won't go into the details of how those can all be done, but I will say that they are important. It's important to make sure that you do pick the best possible method because the results can be extremely different depending on the zoning method that you use. So to kind of illustrate some of the challenges with zone sampling, I just made this little demo of a farm just to kind of illustrate a point that I wanted to make. So if we say that this green map here is a map of soil test potassium, that's the true representation of how soil test potassium is distributed across the field. The white areas is low testing, the green areas is high testing, let's just say. And then let's say we also have the very best method for zoning a field to measure soil test potassium across the field. We might make a map that looks like this. So basically, you can see that they have some fairly good correspondence with each other. The zone map is accurately describing the soil test potassium, and so that's great. But let's suppose we also want to measure something like organic matter, right? And so this is fairly common, right? We're not just going to test for one soil property. That wouldn't make sense. We're going to test for that full suite of soil properties with our zone sampling scheme, right? And so if this map here represents our distribution of organic matter, which I often find in my personal experience that organic matter and other soil properties are not necessarily correlated with each other all that well. But if we apply the same zoning method that we made here with our soil test potassium to our map of organic matter, we can end up with a map that looks something like this, which again follows those same lines that we made here earlier, but it doesn't actually represent the variability of organic matter that might truly exist within the field. And this is because we're forcing that zone to be applied to another soil property map that might not have great correspondence with each other. So to put it in another way, using one zone method for multiple soil properties is really hard because even if you find the exact perfect method for one soil property, it might not be appropriate for another property that you're also interested in measuring at the same time. And so this kind of, again, another little demonstration here, but I want to emphasize that how you draw the line determines the map. So this is why, American politics, they're always fighting with each other on how they draw those electoral boundaries or whatever they call them. because they're fighting over how they can get the most seeds, right? And so it's the same kind of problem that we have here in precision ag, is because how you draw those lines determines they determine the map that you end up receiving, right? So these first zoning methods 1 and 2, these of course are just arbitrary methods, but you can see that just by changing how I'm drawing those lines and dividing up the field, they might give me a completely different looking map compared to another zoning method, right? And so that's why it's really important to look at the zoning method that you choose. But again, this is just a hard thing to make sure that your zoning scheme works across all the different soil properties that you're trying to measure, because those soil properties might not be distributed in the same way. And so the next approach that I'll be talking about here is sensor-based sampling. And so there's several providers in Ontario, including Soil Optics and Swap Maps, and then also Groundwork, which is the company that I work for, amongst others. And so I want to emphasize that this is neither grid sampling nor zone sampling. In my experience, we've kind of been told in precision ag that you can either be in the grid sampling camp or the zone sampling camp. And so if you've kind of heard that message, I'm kind of here to say that there's another method as well. And so that's using sensors or field data to help us predict out the soil properties. And so what's going on here is we're selecting sample points from across the field that are going to give us the most amount of information possible. And so we're not just grid sampling, and we're not randomly sampling the points. We are targeting those sample points to areas of the field that we want to learn from. So we might take a point from a very low area. Maybe it's at the bottom of a hill, maybe it's very high yielding. We might want to take a point here from an area that has got a certain sensor reading, or a certain, if it's very eroded, or it's depressional, right? We want to capture all these different concepts of the field to maximize the information that we're getting from that farm. And with Groundwork's program here, at least we take RTK GPS to ensure that we have the accurate samples locations, that we're taking the samples, the soil from a point or a small area in the field, and that we're not bulking it over a large area, or we're not having variability in the spatial accuracy that could influence our results. And then we also collect sensor data from across the farm, and I'll talk a little bit more about that. But there's all kinds of different layers that we can pull together to help with this approach. And then we're predicting soil properties using the sample points and the farm data. So to just demonstrate this a little bit more, suppose we have, again, this farm, and we've been farming it for a few years, and we've got all these different layers of data that we have collected over time, right? So we might have elevation data, we might have a few years of yield data, satellite imagery, drone imagery. We might have dragged a sensor across the field, or you might have a sensor on your planter, like the Precision Planting Smart Firmer. These are all different layers that we can collect on the farm, and of course, that can be a little bit overwhelming, right? If you have all these different layers of data, what do you actually do with the data that you're collecting? Does it just sit on a hard drive, right? And so this is where sensor-based sampling comes in, is we collect and we standardize all these different layers from across the farm. And then we take sample points from across the field. So let's say these points here. We would then use those points and that underlying all those different layers of sensor data or other farm data layers to help create a machine learning model of how that soil property is distributed across the field. So each one of those points is going to tell us a small part of the overall story as to how that soil property is distributed, and then the computer can learn from those points to help create a prediction of our soil properties. And so here, for example, I've again this shown that this would maybe predict soil test potassium, but you can use that to make different maps for organic matter, phosphorus, and all those other properties that come from a standard soil test. And so, yeah, the advantages of the sensor-based soil mapping is that it has increased accuracy, I would say, over the either grid sampling or zone sampling, because not by magic, but just because we're using those other layers of data to help improve the predictions of our soil properties across the field. And importantly, each soil property is mapped independently from each other. So we're not, kind of biasing our results by forcing it to fit into a certain zoning scheme that we've already decided before we went and sampled. We're waiting until we get the results back and we have all the data to independently map each layer so that they're not, forced to look like each other. And this can also help to reduce soil sampling costs in the long term. And so I'll kind of show some results to kind of look at that next year and how we can actually save on some sample costs with sensor-based sampling. So this is just an example of a field here which we went and we did 1 acre grid sampling back a few years ago. So yeah, obviously, it was a 100-acre farm. We took 100 samples from across the field, so fairly intensive, fairly expensive. And then this is the map here that we made from that. And so this is a map here of organic matter. These next few maps will all be maps of organic matter just to show one soil property that's fairly important. And so I've draped this here in 3D so you can kind of see how the topography of this field is distributed. But down here is a bit of a wet area. This actually, interestingly, is a bit of a hill, but the rest of this is a fairly wet, low-lying area. And so this is the map here that we got with using that high density grid sampling. Um, and so then what's interesting is we came back to this farm a few years later and we took some high value sample points. And so this is using the sensor-based approach. And so our normal density of sampling is around 25 samples per 100 acres, and that's kind of a rough guideline depending on the amount of variability that might exist throughout the field, but that's kind of a rule of thumb that we use. And then we tied that to things like topography, yield, imagery, some sensor data, and we put all of that data into a machine learning model to help us predict out soil properties across the field. And we ended up with a map that looks something like this. So again, this higher organic matter area tended to be in these low-lying wet areas, and then the low organic matter areas tend to be in the high landscape positions, which have low yield potential and have things like lower electrical connectivity. And so if we compare those two side by side, you can kind of see how those two different approaches compare, right? The grid sampling versus the sensor-based approach. You can see that one tends to, look more accurate than the other. And so basically this is kind of showing that we're able to make a better map, but with far fewer sample points because we're able to actually use the underlying layers of data to help improve our predictions across the field. So it's basically making a better map with 75, in this case, fewer sample points than the grid sampling approach did. So just another demo here, so we did another bit of a little trial here to compare different densities of grid sampling and other soil sampling approaches on 3 different farms. We took a 10-acre block and we divided and so then we took 1/8 of an acre samples. So obviously a very, very high density of sampling, but this is more just for a research project. Obviously this would be too expensive commercially, but it's useful to help us to show how those soil properties are distributed across the field and how we can evaluate all those different approaches. So here again, organic matter, black is high, white is low. So you can see that these levels go from anywhere from 2.6 to 4.7 across the field. And then, of course, if our bulk sample doesn't show any of that variability that exists throughout the field, our 2.5-acre grid sample, you can see here, doesn't really show basically any correspondence between what this map is showing and then the underlying 1/8 of an acre grid variability there. So those are kind of disjointed. Once you go to the 1 acre grid, you start to see a little bit of a pattern showing up that's kind of, relating to what's predicted versus what was actually observed with the 1/8 of an acre grids. However, you can see that there's a lot of variation in the 1/8 of an acre grids that isn't present in that 1 acre grid sampling. And so that leads us to the next approach here, our sensor-based approach. And so this is the map here that we made with groundwork to predict organic matter across the field. And so you can see that there's fairly good relationship and fairly good correspondence between those two approaches there, or between the high density sampling and then the groundwork approach there as well. So with that, I just want to summarize kind of what I've been talking about here so far. So grid sampling and zone sampling both can be useful. I don't want to say that they're not useful because they definitely are. They can show variability that's not shown in bulk samples. However, they both have some caveats. Zone sampling suffers from not knowing what the optimum zoning scheme is before you go and sample. And it also assumes that the optimum zoning strategy is the same for all different soil properties. Grid sampling requires very high density sampling to maintain the level of accuracy that you might be expecting. As soon as you start to increase those grid sizes to sizes that are more economically favorable, the accuracy can really take a hit. And sensor-based sampling allows you to reduce sample costs with increased accuracy because you're able to make use of the underlying information that you have on your farm. And so groundwork is one of those sensor-based mapping approaches that we offer the service to farmers and agronomists across Ontario. So with that, I'd like to say thank you, and we can take it from there.
Amazing. Thank you so much, guys, for presenting. I'm just trying to start my video here. Yes, thank you to all three of you for presenting. I think overall we had a very similar theme, of course, that was going on around soil fertility as crop nutrient removal increases with higher yields. It's so important to recognize and monitor soil test data and sampling correctly at the right depth in the right areas at the right time, using the right process for your farm and what your end goals are, while avoiding those challenging conditions such as the extremely dry or frozen ground. All of that is an incredibly great start to anyone's soil fertility plan. So thank you for highlighting all these different caveats and areas of expertise that you are working on and that our farmers across Ontario can be considering. I am going to, I think, I can't. If Caleb, I think you might still be manning the screen.
Okay.
Can you just hit the enter bar or
Um,
change slides? Because the next one is, I just want to highlight really quickly before we jump into questions that, of course, this is still the first of the series of 3 webinars. And we'd love you to be able to tune in, of course, to the following 2 on November 12th and 19th. I'm not sure why
I think
that.
I've given up control. It
I
says to
know. I'm
request, so
just
I'm
not
assuming
sure
that means
why
it's.
I can't. Hmm.
You may have to click those little buttons in the corner, Laura. I was having to do that. The enter and spacebar was.
Oh dear. Um, Sure what I'm doing here. Why it's not giving me, I can do everything else, but not change slides. Um, I will work on that. But anyways, I will just say that we are November 12th and 19th are our next webinars. And they are carrying on for they are highlighting the next parts of the story as we work towards a fertility plan and implementing that plan as we move on. So with that, I want to see if we have any questions, and that's also I'm struggling here. I think you've got do you have control right now, Caleb, again?
I just gave it back to you here. I was trying to see if I
Okay.
could figure it out, but I couldn't.
I'm still not
Can you
able to do
try
anything.
stopping sharing and resharing maybe?
You can do that. Anyways, if there are some questions, so as I'm fiddling with this on my side of things, I'm going to just we've got some comments perhaps that I can. Everybody's saying thank you. Is there any questions that anybody does have? If you do have questions, you can feel free to post them in the chat, or you can also unmute yourself and ask any of the guys who are here with your questions. I know the questions were definitely part of the KSE for your off-calf credits, so please definitely
Well,
ask as you can.
well, if I could jump in and just say thanks to everybody. And I did have some questions about soil sampling, when you think about it over the years. And I think, Colin, you helped me really help understand it. Because what I was wondering about was strip tillage and how the heck do we start doing proper sampling when you've got strips in your field and you got fertility that you've built up feeding your crop. And I know there's different type of strip till units to put fertilizer down. Some incorporates and mixes the soil. And I've often wondered, yes, how do you do that? And I think you mentioned, and I just want you to confirm, you just want to do more samples. I just wondered how many more should you be doing?
Yeah, so I think that's a good point that we kind of lump strip till in together as one kind of practice. But yeah, depending whether that fertilizer is mixed within that zone and how wide that zone is, if it's 6 inches or 10 inches, it may differ how many samples you need from that zone. Basically, you're more or less trying to take that wherever that band is and average it out across the rest of that row width. So if you're in a 6 inch band, you're maybe one out of every five samples you'd be taking that, assuming that fertilizer is really mixed in well within that band. And if it's if that strip tiller is actually putting down a deeper band instead of that mix, it may be something where, similar to a 2x2 band that you're taking one out of every 10 samples or one out of every 20 samples within that band. So kind of important to know how that strip till system actually works. But if you don't, and if you're in a field that you can't tell where that strip was, if it was put there 2 years ago, yeah, I mentioned just take more samples. So it may be instead of that 20 samples, you may be 30 samples, something like that, or 30 cores per sample. Mix them together. Basically, the more you get, the more accurate it is, just to give a better representation because you've got more of a chance of hitting that zone at a regular interval. So yeah, the more the better, but yeah, 20 is kind of that absolute minimum number.
Thanks, Colin. Also, kind of wondering with that too, a lot of times retail businesses are doing the soil sampling for their customers. And, a lot of times they just go out to the field and they either have a summer student or they have somebody to go sample it. How do they know that they're hitting the right spots of the field? Is there any consultation beforehand, or how does that work? Or what should a farmer do to be proactive with their soil sampling?
Yeah, and I think that's something that absolutely the proactivity that's got to be part of it. So, from a retailer's perspective, they're going across a lot of different fields, a lot of different operations with different practices. So it's kind of impossible to know unless you're talking to the farmer directly, how exactly that what practices have been used, how that fertilizer or manure has been applied to that field. So I think that conversation's got to happen a bit more regularly to really improve the accuracy of that sample.
Great.
Thanks,
I
Colin.
do have two questions here that came into the chat. One is asking what the average cost of a basic soil test is. So I'll let you answer that and then I'll ask the next question follow-up. Does anybody have a thought
Yeah,
on that?
like it'll be give or take around $20 per sample is ours is 19, I think, is our going rate on a basic test. So that'll give you the macronutrients, organic matter, CEC, and your base saturation numbers as well.
Another question is just wondering what the difference between SWOT, soil optics, and groundwork sensors are. Caleb, I think that would be in your.
Yeah, I can take that. Yeah, so SWOT and groundwork, we both use like an electrical connectivity based sensor. And then in soil optics, they've got a radiometric sensor, which basically means it's measuring natural radiation from the soil, and then they're kind of using that to predict soil properties. And so I guess the difference with groundwork is that we would be using as many layers as we can, right? So we're not just going to look at only our sensor data, we're going to look at our yield and topography and imagery and all those other layers as well.
Amazing. Thanks. So just for reference, of course, the CCA CEU code is up. The OFCAF KSE, if you are needing that, the link is now in the chat. That QR code is taking you to a different knowledge sharing event. So the link is now in the chat for those who are looking for those. And Anastasia from OFCAF or OSCA is just making a note. So please do take note of that if you are needing those. Another question that has come in is what soil test would you recommend for a former pasture field that is now growing sweet corn and other vegetables that did quite poorly this year? They're wondering if it's a basic or complete, if they should look into soil nitrate, different properties of soils. I'm not sure if any, sure, any three,
Yeah,
all three of you can answer this, but whoever maybe is.
yeah. My first recommendation would be to kind of look at the low-hanging fruit of what the what the issues may be within that soil if it's growing poor veggie crops and sweet corn. So oftentimes, not always by any means, but pasture fields they tend to be relatively high in organic matter, which is good, but often quite low in phosphorus and potassium, especially. So I think that's kind of where we've got to start is looking at pH. So making sure that pH is in order and phosphorus and potassium. And so you'd get that information with a basic test. That being said, if you've already got that basic test and your pH is in line, your phosphorus and potassium are in line. Then you can start looking at your micronutrients and your secondary nutrients like magnesium and sulfur to see if they're really causing a kind of an imbalance or deficiency. But I think the basic if it's the first time growing anything other than pasture there, the basic is going to give you a pretty good idea of what's going on with the macronutrients and pH, but absolutely a complete test might give you a better overall picture of the micronutrients as well.
Colin. There's another question here it's asking about going back, your thoughts on about going back to sample a specific GPS point year after year. And I do think that is kind of what some of these sampling systems are doing, but if one of you wants to take that.
Yeah, I think I'll maybe take that
Sure.
here, but you guys feel free to chime in. I think that's really important to do. Like I think that's going to have the lowest variability, I guess, to if you're wanting to track trends over time, especially if you're doing things in a spatial way, looking at variable rate fertilizer, that kind of stuff. And so that's kind of where the approach that I'm kind of working on right now is you can, map the field once, and then you can come back and you can remap the field just by sampling those same GPS points that you originally sampled, right? So I think from my perspective, that's a good idea, but open to what you guys want to add to that as well.
Yeah, I think having that trend over time, I think it's incredibly important. And yeah, we maybe don't spend enough time on, looking at that timeline of the past, 10, 15, 20 years of cropping and how that soil tests have changed over time. So yeah, no, I think no matter what system you're using, if you can kind of look at that and assuming you're taking that sample at the same part in your rotation, same time of year, all that thing. I think there's some benefits to going back to that same point and being able to compare that soil's history.
Great, thank you. Another question here is, what are your thoughts on soil samples in the fall after corn? Should samples be done typically after soybeans? Maybe Colin, you could take that perhaps too, or Danny, or whoever, maybe
Yeah,
Danny too. But
yeah, I can comment on that. And I, from my point of view, I think either of those options are good options. When we're talking a basic soil fertility test, sampling after corn is a good time of year to be doing that as well. Uh, as well as after the beans. Um, yeah, if we're talking like cyst nematode testing, like obviously you want that to be done as close to a bean harvest as possible. But in terms of a fertility test after corn, there shouldn't be any issues with that. If you can get the residue out of the way and get a good 6-inch depth soil core there, and it's not too wet, obviously, as well.
Great. No, and I think in general, all of us would probably agree like a soil sample as opposed to no soil samples is still a huge bonus for planning your soil fertility for the upcoming year. So that's great. So if you do, there's no more questions that I'm seeing here in the chat, but if you do have a question, feel free to toss it in the chat or unmute yourself and ask our presenters. I'll give it another minute or so, but overall, thank you to everybody for attending. Reminder of the next 2 Wednesdays, we are also having some soil fertility webinars that will follow up on this one. And you will get reminders for those in your emails, just as you did like for this one as well. Yeah, a reminder that the link for your off-calf KSEs are in the chat function. Yeah, of course, if there's anything else, please, I think all of these 3 would be willing to take questions at another time if something does come up after this presentation. But with that, I think we will sign off and just thank you, Danny, Colin, and Caleb for talking to us and presenting today. And thanks to everyone for joining.